Afternoon, everybody. Thanks very much for the opportunity to speak to you today. As you can see, I've got an incredibly exciting topic to wrap things up with. Hey, is that dry or what? Is that, that's an exciting topic to me, and I'm going to show you why I think you guys will agree after the next 18 minutes or so. First, a little bit about, before I get going here, a little bit about Structurlam Products. Next year is a very exciting year for us. We celebrate our 50th anniversary. We started in 1962 right here in Penticton, and still here in Penticton. We employ about 100 people, which means that we support about 100 families directly here in the valley. And I think it's important to remember the economic side of sustainability, and then all the suppliers that supply Structurlam as well. So major employer here, and will be for a long time to come. We provide heavy timber packages and provide primarily glue-lam packages like the beams and the columns you see in this beautiful building here. And we have a brand new product called Creston, and I'm going to show you that as well as we work through the presentation. We've done many, many iconic buildings, and I'm going to show you some nice pictures of some of the ones we've done, both internationally, or both in North America and internationally. I'll just focus on the North American ones today. So, as you can tell, I'm a wood guy. So is everybody else that works at Structurlam. We love working with that material, and it really has become, it's quite a renaissance lately as we apply new technology, and we've come up with new engineered wood products, and I'm going to show you a couple examples. The nice thing about wood, of course, it's renewable. It's essentially captured solar energy. It's sustainable. Every bit of fiber that we use in our glue-lam beams all comes from sustainably managed forests. It also it captures a great deal of carbon as well. It's incredibly strong. You can span long distances amazingly with engineered wood products, and of course it's beautiful. These beams have been stained dark brown, probably because the architect here wanted more of a solid wood look. Often people just leave them clear as well, and I'll show you some examples of that. There's a lot of engineered wood products out there. Fortunately for you guys, I'm only going to talk about a couple of them. And they've been around for a long time. The oldest one is plywood. Plywood's been around for 100 years. And it is still one of the best engineered wood products out there. Many of these were invented in the 1970s, like I-joists and LSL lumber. It really caught on in the 1980s. Why do we have engineered wood products, or what's the common thing about them? And that's that you take parts, fiber, veneers, or strands, and you basically glue them together to make a more stable product that's stronger than wood, and it's very, very consistent. The two that I want to talk about is glue-laminated timber and cross-laminated timber. Glue-lam's been around for about 50 years, but the interesting thing is that technology's moved along, and we're applying a lot of that new technology to an older engineered wood product. Cross-lam is brand new. Here's just an example of some glue-lam. Basically, you're taking very high-quality dimensional lumber, 2x4, 6, 8, 10, 12, and you're face bonding it together into big, larger cross-sections like that to make essentially beams and columns. It's got a couple of really nice advantages. You can curve it, and we do an awful lot of arch work. It's, again, very, very strong. And it's aesthetically pleasing. As far as I'm concerned, it's the best looking engineered product out there. And when we talk about glue-lam, what's changing, or what's allowing us to use it in a brand new environment is three technologies. First is 3D modeling, which Structurlam pioneered in the use of heavy timber packages. The connection design, I'll talk about these ones above us, and CNC or robotic machinery. So those three things are really changing the game when it comes to using glue-lam for non-residential, and by that I mean commercial, institutional buildings, like this one. Here's 3D modeling. This is the Colonial Library. On the left you see the rendering of the building. On the right you see the actual building. We take the two-dimensional architectural drawings and engineering drawings. We create a 3D model, and in that model we populate all the wood members and all the steel connectors that go into it. Some great advantages. It eliminates a lot of errors. You can often see conflicts inside that model that then get fixed. And the big advantage for us is that we take right from that 3D model the computer files, and download those right onto our robotic CNC machinery. This one here is the 3D model of just a portion of the building that we're in right now. On the top you see the model, on the bottom you see the rendering of it. If I zoom into that though, every single steel connector, every wood member, every nut and bolt and screw that went into that is actually put in that model. Here's a zoomed up version of it. There's the trusses, the exact same ones you can see above you, these three-dimensional trusses that in this case the engineer designed. And again, you're seeing some really elaborate, fancy steel connections. Some of those connections now come from Europe. They're off-the-shelf systems. Some of them are designed here in British Columbia, but it's an incredible advance we've made in using wood by using very sophisticated connectors. But you can't use sophisticated connectors unless you have the machinery to be able to frame for them, and I'll show you an example of that. So this is actually located in our plant here in Penticton. It's the largest 5-axis CNC gantry-style CNC in North America in the wood products industry. It can go to any angle, it can cut, it can notch, it can shape, and that's what allows us to use a lot of those fancy connectors that I showed you before. Just a quick shot, I think I can show you this in action. There we go. So there it is. In that case, you place the wood member on a 110-foot bed, and that this machine here, it's using the slotting machine. There's the drill. There's it with the saw. It actually goes back and exchanges its bits and its tools automatically as it goes along. And just a fantastic piece of technology. There it is, changing its tools right there. And here's an example. The last one here is when it's doing some shaping. So this is how we get elliptical columns and round columns and things like that. So pretty impressive machine. Well, there's more technology to come here. Anyway, here's what it looks like after it's been through all that exercise. There you can see some arches. These are destined for Saanich Middle School, just outside of Victoria. You can see that it's been coated now. It's got end caps on it. You can see how the CNC is actually framed for the steel connectors, and off the road and down the road they would go. So that's kind of a finished product. When you combine all that technology, the ability to use those fancy connectors, that CNC machinery, and that 3D modeling, you can do some amazing stuff. And this, I think, is probably the pinnacle of what Structurlam has done. This is the most complicated wood structure in North America. It's the Art Gallery of Ontario. You can see down below it's still under construction there. It was finished about, I think it's 2 years now. And it's a facade that goes the entire 1 block length of Dundas Street. I don't know if anybody here has seen it. It is spectacular. And the architect here, Frank Gehry, who's actually Canadian and an extremely famous architect, wanted to have, if you notice, I don't know if you can from the model, but what's holding that glass up are these arches that curve back into the building, and they actually start vertically in the middle, and the farther you go to the outside, the more of an angle they're on. So the geometry changes at every single point along there. So horrifically complicated, but let me tell you, the end result was worth it. There's a shot inside of it. So there's not two pieces in that entire facade that are the same. Every single piece is different. So you can't do something like this by hand. You need to have the technology that Structurlam has to do it. The nice thing was that I stood right here in front of this little chair right here when they opened the building, and to watch the impact of the people as they came from the right-hand side of the screen here, and then it came down. The first thing they do is they look up and they just go, wow, and the jaw would drop, and the next thing they would do is they go up there and they put their hand on that beam over there. Because human beings have a connection to wood, and that's what, just one after the other. You had to go over and touch it. So it's kind of impressive to see, a very proud moment for us. Here's the, this thing working here. Here's the shot of the Olympic Oval. These actually have a steel frame inside them. Each one of those arches is made out of a V shape like this, and there's 8 pieces, 8 75-foot pieces that span 300 feet. If anybody of you have been in the Olympic Oval, you know how impressive it is. Made right here in Penticton. This is the largest wood roof in North America. This is the Raleigh-Durham Airport in North Carolina. Again, we shipped them all the way across the North America here. You can see by the guys on the man lift there, this is still under construction, the size of those beams there. That's an impressive building. This is, we did 6 buildings for the Olympics. They were very supportive of the use of wood. This is the Cypress Lodge. This is where the snowboarding happened during the Olympics. This is an interesting one. This is a pedestrian walkway, if you can believe it. rather dangerous one, you'd think, huh? There's about 8 of these that go all the way along the Toronto waterfront. Here it's made out of yellow cedar. Yellow cedar is extremely resistant to rot, decay, insects, things like that, and so it's just actually, it's not treated at all. There we go, that's the Brentwood SkyTrain station. I don't know how many of you taken the SkyTrain in Vancouver. That's that station there. Next slide. This is the Michael Smith Laboratory at UBC. Those aren't just aesthetic, they're actually holding that roof up. Pretty impressive. Ballard Library in Seattle. Next slide. This is an interesting one. This is a pedestrian walkway that goes across from Metrotown and Burnaby, across this Kingsway, I should say, and it's about a 145-foot span. I wanted to bring this slide in here. That's a pedestrian walkway. This one's a secondary highway bridge. This picture's from last November, just being installed. It's a pressure-treated glulam, and this is the result of British Columbia's new Wood First Act. So any structure that has wood in it, or is being partially funded by the provincial government, they want a wood solution now. And it's amazing for us to see, because we hadn't built a glulam bridge in almost 40 years. So it's nice to see that happening. That one's 103 feet long and 5 feet deep. You can see the guy on the lift. It weighs about 20,000 pounds. And and that's how we get them down the highway when they're that big. So what happens is that there's actually in that little pod there in the back, a guy actually drives the back end of that truck. So there's a pilot car in the front, one in the back, and there's a guy driving the front end and a guy driving the back end. This is a little bit of the future. This one here, we're bidding on this one. This is done by the same architect that did the Art Gallery of Ontario. This is the Guggenheim Museum in Abu Dhabi. Essentially the design is if you had a whole bunch of blocks of different shapes, cones, squares, rectangles, and you dropped them on the floor, that's essentially the design of this building. Almost all the cones are out of glulam. So this will be the largest glue-laminated wood structure in the world when it's done. So, and we're in the running. It's going to be, it could be the ultimate really for us. A bit scary actually, just to be part of it. So that's the glulam side. This is brand new. Last week, Structurlam opened, I don't know if you saw it in the paper, but Structurlam opened our brand new cross-laminated timber facility. Here's an example of some of the cross-lam panels that are made there. It's quite different than glulam in that what you do is, again, you use primarily 2x6 material, and say if you're making a panel that's 30 feet long and 8 feet wide, you run the 30 feet finger jointed 2x6s lengthwise, face glue it, then put the 8-foot finger jointed smaller pieces perpendicular to that, 9 degrees, long ones, short ones, long ones, short ones, you build up the panel like that. We have an opportunity, our capacity is a panel that's 10 feet wide, 40 feet long, and 13 inches thick, which is a ton of wood. That's almost 10 tons if we wanted to make a panel that big. Why would you want to use that much wood, right? The reason is that just the way the glulam beams replace steel, wood replaces these cross lams are going to replace concrete. So I'll give you a quick example. So what happens is that after the panel is made up, it goes into a press. It's pressed for about an hour, hour and a half. When it comes out, it's a raw panel. We then take it and we square it up and we plane it. It can then be used for floors, walls, and ceilings. Again, it's not destined to be a residential product, unlikely. It's more of, again, a commercial product, and it's destined to replace concrete. Here's some of the panels. It was invented in, the product was actually invented in the 1990s in Switzerland. It's really gained popularity over there, especially in the last few years. Here you can see a wall panel probably being flown in. It has a lot of advantages to it. I'll just walk you through a few of them. Just a couple of shots there to show you. Everything is pre-cut in the factory. Here's our new factory. This is some shots of it here. All the equipment in this one came from Europe. The top two pictures of the in-feed system, so everything is automated. The bottom left is actually the press where it goes in. It's a hydraulic press, and it presses down at 80 psi through the whole panel. And then on the right-hand side, how do you plane a panel that size? You buy the world's biggest planer. That one's called the Big Master, and it's aptly named. It's a monster. So it's quite something to see that. It planes all four sides. It has the capability of following an arch, planing all four sides of an arch as it goes through. So pretty sophisticated machinery. Here's the panel after it's gone through that. If we need to, we have our CNC machinery in Penticton. The panels are being made in OK Falls, And so we do, if we have to run them through the CNC machine that you saw, we still have to bring them back to Penticton. In the future, we're going to buy a second CNC machine to go out there. There's a panel that's ready to go, essentially. And here's a couple of examples. These ones are all from Europe because our new production facility is the largest and really the first one here in Western North America. So it's brand new. Here's an industrial building. You can see the panels going into that. Here's some single family. That's one I shot there in Austria last year. Here's some multifamily applications. Commercial, church on the right, some other building on the left. There's an institutional picture as well. So there's a lot of different applications. We primarily see it as a commercial product. So what's the advantages of it? First of all, of course, it uses, as I mentioned before, it has the advantage of using a lot of wood. The advantages can all be distilled down to installation, structural, and environmental. Installation. This is a big one for us because these panels are all pre-cut in the factory. They're put on the truck. They could literally be taken right off the truck and installed on site. Imagine the effort of putting up framing if you're going to do concrete. Even if the price was the same between the wood and the concrete option, we'd win a long way just on the speed of installation. Minimal waste. This is an actual picture of a 9-story wood building, which I'm going to show you later, in London, made out of CLT panels. And that was the waste that was remaining after the building was done. Obviously, when everything's pre-cut ahead of time, you minimize site waste. Structural strength, and obviously they're incredibly strong. You can get rid of a lot of the secondary purlins that you might see in a building like this. You can see the secondary purlins between the main beams here. If this roof had a CLT on it instead, you wouldn't need those. So there's some really good structural benefits to it as well. And of course, very much like a concrete slab, and unlike glue-lam, it spans both directions. So you could actually hold that slab up with just columns if you wanted to. You don't have to actually build foundations to hold it up, and of course the cantilevering opportunities there. I'm sure the architects will like that. Right, Nick? So this is another thing is that it's 6 times lighter than concrete. So, so now you don't have to have big, sophisticated and heavy foundations in there because you have a much lighter building on top of it. And if you have heavy foundations and you have them on poor soils, then you have to do a lot of preloading on that to get ready for a concrete building. Again, there's a big advantage here just because it's light. You guys want to see this one? Okay, let her go. I can't get it going. So this is the largest earthquake test. This is in Japan, and this is the equivalent of the Kobe earthquake being tested on a CLT building. And the results were phenomenal. Moved around a lot, and absolutely no damage to the building whatsoever. Shows a couple of different angles of it here. And you can see how much it moves around. The last one here gives you a real feel for how what a 7.2 earthquake was like. On the bottom here, they'll show you. So here you go. So it's pretty violent earthquake. Yep. Oh, no, there was no windows in this building. They were just testing the structural aspect of the cross-lam panels. Okay, so back to the... Okay. Next then. So environmental, obviously with that much wood, you're sequestering an awful lot of carbon. Next slide. And low embodied energy, another really nice thing about it, it takes an awful lot less energy to make a panel like this than it does the equivalent in concrete. And of course, if you come and you'll see the panels being produced at Okanagan Falls now, we're using basically SPF, whitewood, and a lot of mountain pine beetle killed lumbers going into those. So that's the opportunity here to take a very underutilized wood material and turn it into a high-valued product like this is amazing. We're going to also look at doing the same with hemlock. And of course, if the architect wants to, you can actually, the panels look good enough, frankly. We're going to have two different grades. We'll have one that is non-exposed, where you probably put drywall over top of it, or we're going to have an option to have an exposed panel. So a higher grade of lumber would be on the outside of an exposed panel, and you could just leave it like that. This is just to wrap up the opportunity here to build tall buildings. As I mentioned before, there's a 9-story building already in London. There's even taller buildings than that already on the books in Australia and in Europe. And in British Columbia here, the intent is to build a 10-story building in Prince George here very quickly. The other opportunity is on the right-hand side. Even in a traditional, we're not building this product to replace standard stick frame. We don't think that's an opportunity, but if you've got a 4-story walk-up, typically we build a lot of those condominium buildings. We like the opportunity of replacing the elevator shaft and the stairwells with Crosslam. A couple of examples from Europe again, and the last slide here is that this is the Murray Grove building in London. That's the 9-story building that I was mentioning, and it's the tallest so far, but it won't be for long. That's it. Thanks very much.
Thank you, Andrew.
Okay, thanks.
Pretty good.